Hello. After we did the developments of the prisms and the cylinders, what you can see even over here. Next level, we're gonna tackle the pyramid. The pyramid, although it's the same family of the solids, the development is a bit different. To start up, prepare an A3 paper with a border and the title block. In the title, write development prisms, pyramids. Okay, development pyramids. So, as we said with the prisms and the cylinders, prisms they take the name according to the base. That is a square base prism, it means it's got a base of a square. A triangular prism, it means it's got a base of a triangle. In the case of a circle, obviously it's called a cylinder. With the pyramids, it's the same. If I have a square base pyramid, it's it means the base is a square. If we have a hexagonal base, it's a hexagonal pyramid, and so on. To start up, we're gonna draw a square pyramid. This drawing is gonna take the full A3 paper. Okay. To draw the pyramid, we're gonna draw the plan. I'm gonna do a circle radius 35. I'm gonna tell you where we're gonna do the center line. Okay. With the outline, I'm gonna draw the square. So the square I'm gonna position in this place. The center line we're gonna do it 94 or 100 millimeters away from the border itself. Okay. The difference between the prism and the pyramid is that the pyramid it's got an apex, which is the highest point. So I'm gonna show it over here. The height of the pyramid I'm gonna do it 100. So you're gonna measure 100 millimeter, and with the outline I'm gonna join to produce the elevation, the front view. Okay, so that is the front view for the square pyramid, and this is the plan. For now, it's quite straightforward. I'm going to remove the measurements. Right, the circle, we're going to do it radius 35. So we're going to do radius 35 from there till there, 95 or let's say 100, and the height of the pyramid is 100. When we say the height, we refer to the height. It's always perpendicular height. That is from the base, from the center of the base to the apex. This is the apex over there, the highest point. Okay. For now, it's straightforward. To create the end view, we need to do a 45 degrees line. Again, from the plan, we project the lines. We transfer them up using the 45 degrees line, which is this line over here. We used it already. Obviously, the end view is going to be in line with the front. Even the height is going to be the same. So basically, all I need to do is join to create the end view. If you're noticing, the end view and the front view are identical, but obviously they are representing different faces. Okay. Preferably, if you label the points, okay, give me an idea. Okay, over here. I'm gonna label the points using numbers. So that is point 1. Okay. Here we're gonna do point 2. I'm gonna rearrange the numbers 3 and 4 accordingly. So here, this point I'm gonna label it as number 2, this as number 3, and this as number 4. As we did the prisms, we're gonna transfer the numbers according. So that is my 1, and my 1 is over here. Here I've got my 2, and my 2 is over there. Also, at the back there's number 4. This is solid geometry, which means there are lines which are hidden at the back. Here I have number 3, and number 3 is over there, and number 4 is over there. Okay, so that is a complete orthographic projection of a square base pyramid. Now next we need to do the development. The development of the pyramid is different from the prisms and the cylinders. If you notice over here, the development of the prisms and the cylinders is always in a form of a rectangle. In this case, it's gonna be in a form of an arc. First thing we need to do is you do a cross wherever you want, which is gonna be the center for the development. I created sort of starting point. Next, which is very important, we're gonna open compass from here till there. In my case is 106 millimeter, and open compass 106 millimeter. I did a complete circle, but in your case you don't need to do a complete circle. Start line, preferably do a vertical line. Then what we need to do, we're gonna measure with a compass this side of the base, which is 49 millimeter. And with the compass I'm gonna transfer the 49 millimeter on, and I'm gonna do 4 points. In your case you're not gonna do a full circle. I'm gonna do it outline so you can understand better. Okay, all you need to do is from here join to each point which is representing this side of the base, and I'm gonna join to the apex again. These I'm gonna remove them. In your case you're not gonna draw full circle, just a tiny arc with the compass. And here we have what we call the folding lines. We're gonna get back to them later. So for now we have plan, a front view, an end view, and the development of a square base pyramid. As you're noticing, the drawing is not that difficult. But the most important thing which we have to follow is this. Important to learn the meaning of true length and from where I'm gonna measure the sides. I'm gonna use color to identify what I'm saying. So, when I told you to measure the base, we measured this one, which is 49, because that is the real measurement of the base. If you measure from here till there, that is not properly, it's not good, it's not true length, because that is bent. So make sure that whatever you measure, it makes sense, it is real. So to measure one side, you have to measure from the plan. In my case, I picked up that length. With reference to the front and the plan, for sure you are noticing that this